Okay, if you are new to this channel, please make sure you subscribe, like, and make sure you share this video, please. Now today, we want to talk about the integration by parts. Integration by parts. When I say integration by parts, the first thing we have to notice is that the formula for integration by parts. What do we use? We use integration by parts is uv minus integral of v du. Now this is the formula we use for integration by parts. We use uv minus integral of v du. Now we will now come back to the questions given. Now we have x and sine x dx. So this is our u, while this is our v. This is our u, this is our v. That is the first thing we do. Label it. Label it. You cannot use substitution for this, because if you use substitution, it cannot work. You can try it on your own. Now, what do? After you've labeled it like this and you've written this formula, mind you, we are going to integrate this. Whatever you see here, we are going to integrate it. Please do not forget. Now, what is my u? My u is actually x. And what is my v? My v is sine x. And what is the integration of sine x? The integration of sine x is going to be minus cos x. Integration of sine x is minus cos x. I'm bringing down minus cos x here. But instead of me writing it like this, I can just the same way write minus x cos x minus integral of, what is v again? V is minus cos x now. You are going to write minus cos x, not sine x. Now, how am I going to get the u? We are going to look for the u also. How are we going to get the u? Now, from this u equals to x. U equals to x. So I will now find the u dx. If I differentiate this, the u dx, that is 1. U dx of x is 1. So don't forget, I'm looking for du. If I cross multiply, that means du equals to dx. That means my du is equals to dx. Now, we have minus x cos x minus times minus, that is plus integral of cos x dx. So that means we are having minus x cos x plus. Now, what is integral of cos x? The integral of cos x will give me sine x. It will give me sine x. Sine x. That means everything plus c, arbitrary constant. So that is the answer for x sine x dx. The answer is minus x plus x plus sine x plus c. Now, let's take a look at another one. We have evaluate integral of x squared cos x dx. Now, if you are having this is also integral by parts. What do? We are going to label it. The first one is u, the second one is v. And according to our formula say uv minus integral of v du. uv minus integral of v du. Now, like I said earlier, that we have to integrate this v. What's our u? Our u is s squared. Now, what is v? Our v is cos x. And what is integration of cos x? The integration of cos x is actually sine x. It's sine x. So we are going to write the sine x here. So minus integral of, what is our v? Don't forget that our v now is now sine x, no more cos x. We are going to write this thing here. That is sine x. So we are now going to get our du. How do we get our du? We are getting our du from this. We say u equals to x squared. I can as well find du dx. Du dx is 2x. So if I cross multiply, that means du equals to 2x dx. 2x dx. Don't forget, I'm looking for du. So du is already 2x dx. What do you think I did? I cross multiply. This one over 1. If I cross multiply, so dx is coming back at the back of 2x here. So I've known my du to be 2x dx. That is 2x dx. That's my du. That's my du. So what's next? So I'm going to have x squared minus sine x minus. So I can bring out. I can also bring these 2 out in front of integration. That means 2 integral of x sine x. 2 integral. I brought these 2 out. So I'm having this x here. I just bring this x in front of sine x. That means x sine x dx. Now, after I've done this, if you look at it again, you have to start this one from the beginning back. Like for integral of x sine x dx, because you have to apply integration by parts for this one as well. What do we do again? We label this. That means uv. Uv again. We apply our formula for this. That is uv minus integral of v du. Uv minus integral of v du. And what is our u? Our u is actually x. Do not forget that we are going to integrate this v. And what is integration of sine x? That is minus cos x. So you can say minus here and put your cos x here. That means minus this minus that is here minus integral of. Do not forget our v is no more sine x. It's now minus cos x. Minus cos x. And how do I get my du? Do not forget that our u is x. Our u is x. If I find du dx equals to 1, which means that du equals to dx. Du equals to dx, and du equals to dx. So that means I'm going to have minus x cos x minus times minus, that is plus integral of cos x dx. That means minus x cos x plus, and what is integration of cos x? That is sine x. That is sine x. Now do not forget that from here we use integration by parts from here. So that means I'm going to bring this answer to come and join together with this. So that means our final answer is going to be x squared minus sine x minus, let me open a bracket, minus 2, open a bracket, and what did I get for me? I got this, open a bracket, minus x cos x plus sine x. So that shows that I'm going to have something like x squared minus sine x minus and minus, that is plus 2x cos x minus times plus minus 2 sine x, everything plus c. So plus arbitrary constant c. So that's for number 2. Now let's take a look at number 3. If we are given something like this, evaluate integral of x log base e times x dx. You are given this to do. Now, in case, do not forget our formula still remain. uv minus integral of v du is still our formula. But in this case, anytime you are given log in integration by parts, so before we were labeling it as uv, but in this case, because of log reading that is there, it's going to be vu. Please, you have to take note of that. Anytime you see log readings in your integration by parts and you want to label it, you don't label it as uv, you label it as vu. Now, what is our u? Our u is, okay, like I was saying, anytime you are dealing with integration by parts and you are having log, so you will change the way you are labeling. It will not be uv, it will be vu because of log. Now, what is our u? Our u is now log x base e. And do not forget, we have to integrate this v. And what is our v? Our v is x. Now, if you want to integrate x, that will be, there is a power of 1. That means plus 1 all over 1 plus 1. That means x raised to power 2 all over 2. That is integration of x. X raised to power 2 all over 2. That means I'm going to have something here, x raised to power 2 all over 2 minus integral of v. And what's my v now? My v is this. Don't forget, s squared all over 2. And how will I get my du? I have to get our du. And you know that our u is actually log x base e. That's our u. If I differentiate this, it's going to give me 1 all over x. 1 all over x. That means my du dx will give me 1 all over x. So if I cross multiply, it will give me du equals to 1 all over x dx. Du equals to 1 all over x dx. That is my du. That means I'm having for my du, which is also the same thing as x, 1 all over x dx. So the next thing we do is that write log x squared all over 2 minus integral of s squared all over 2. I can as well bring this 1 over 2 outside. I can bring this 1 over 2 outside. 1 over 2 minus. So I'm having s squared here all over x dx. So that means I'm having log x base e x squared all over 2 minus 1 all over 2 integral of s cancel x, we have 1x left dx. So I will now need to integrate this x. That means you are having, so that means log x base e x squared all over 2 minus 1 all over 2. And what is integral of x? We all know that it is x squared all over 2. X squared all over 2. That is plus c. So we can actually just make it more like we have. I can just write it like this: x squared all over 2 log x base e minus x squared all over 4 plus c. Also, I can still factorize it because I'm seeing something common here. In case of objective, if you notice x squared and n squared, you can just say x squared all over 2 into bracket log x base e minus 1 all over 2 plus c. So if you want to factorize, better. So that is integration by parts. We have integration. I talk about the powers of sine and cosine. Powers of sine and cosine. Now, evaluate integral of sine square x dx. Now, I want to talk about the power of sine and cosine. We are given that we should evaluate the integral of sine square x dx. How do we do this? Now, if you can remember from our trigonometry, that when we have cos 2a, that is cos a plus a. So it's going to give us cos a minus sine a from our cos 2a, if you could remember. So that means cos a times cos a, that is cos square a. Cos square a minus sine a times sine a, that is sine square a. If you remember. So because I'm working towards this, so I need to let this one stay. And what is cos square a? Cos square a is also 1 minus 2 sine square a minus sine square a. Now we know that it is 1 minus, this one will give us 1 minus 3 sine square a. Now again, I can also say, if I have cos square a minus sine square a, if I make this one I change this one initially, I can also make this one to stay and say cos square a minus open bracket. This one will give me 1 minus cos square a, which is cos square a minus 1 minus and minus plus cos square a, which will give me cos square a plus cos square, that is 2 cos square a minus 1. Now, if we can actually remember this, that means we will be able to solve it. Now, what are we now looking for? If I say sine square x, oh sorry, let me bring this one inside. 1 minus, with opposite. When we have, this is under power of sine and cosine as well. When we have it like this, what do we do? Number one, you can just use substitution. Just say u equals to sine x. I want to look for dx. How many du dx? What is differentiation of sine x? That is cos x. Don't forget, I'm looking for dx. If I cross multiply, that means du equals to cos x dx. Since I'm looking for dx, I'll divide this out by cos x. All over cos x, all over cos x. This cancels this. That means dx equals to du all over cos x. Du all over cos x. Since I've gotten my dx, that means integral of, I've turned sine x to u, I represent by u, that means u square multiplied by cos x. What's my dx? My dx is du all over cos x. So what's the next thing? As you can see, because x cancel cos x. Okay. So we are having left integral of u square du. Now if I integrate u squared, I'm going to have u raised to power 3 all over 3. As you know, we add 1 to this, that's 2 plus 1, that's 3, and you bring it down to the denominator. So plus c, or we neglect the u. So we now substitute for our u back. Don't forget that u is sine x, that means sine x cube all over 3 plus c. Plus c. Again, if we are given something like this, evaluate integral of sine x dx. We are given something like this. What do we do? As you know that this cube, I can as well write it as sine square x sine x dx. If I split it into 2. And we know that sine square x also means 1 minus cos square x. As we know in our integral, in our trigonometry, this bracket sine x dx. So I can use this sine x to open the bracket. That means I'm having integral of sine x times 1, that is sine x, minus sine x times cos square x, that is sine x cos square x dx. That means I can use integral to open the bracket. That means integral of sine x dx minus integral of sine x cos square x dx. In this case, what would I do? So I need to undo this one like the previous one I did. I'll just find the integral of sine x ordinary. That means I'm going to have, what is integration of sine x is actually minus cos x. That means if this one is giving me minus cos x, so I have to now solve this. If I want to solve this, that is, let me just say cos square x sine x dx. I want to solve this one in a separate way. That means we are having, like I told us, we can represent this one by u. U equals to cos x for us to look for our dx. We now find du dx. We are looking for dx. What is differentiation of cos x? That is minus sine x. If I cross multiply, I will have du equals to minus sine x dx. But I'm actually looking for dx. That will be all over minus sine x, all over minus sine x. This cancels this. We have dx equals to minus du all over sine x. Now that I've gotten this, my dx, what will I do? I will need to go and substitute it back. So that means integral of this is u square, because of the square here, multiply by the sine x, multiply by, what is my ds now? My ds is minus du all over sine x, all over sine x. So that means we are having this sine x cancel this sine x. So I'm going to have u cube, if I integrate u cube, all over 3. That will be the integration of u squared. But don't forget the minus. The minus will be reflected. And I will need to substitute for u plus c. If I substitute for u, the u is cos x. That is open bracket cos x raised to power 3 all over 3 plus c. But don't forget, these are two things. Before I even write plus c, I need to go and bring this to come and join with this. That means our final answer is going to be, this is first answer, minus cos x raised to power 3 all over 3 plus c, all over 3 plus c. And because there is a minus a before, there's a minus a before, minus, and the minus is coming here before. So if you look at that, is minus cos x, minus and minus, that is plus cos x cube all over 3 plus c. So lastly, we are having, under the power of sine and cosine, under the power of sine and cosine, we are having integral of cos cube x dx, cos cube x dx. What do you do again? He said integral of cos square x cos x dx. And you know cos square x is 1 minus sine square x cos x dx. So that means integral of, we use cos x to open the bracket. Cos x comes out like this. Cos x minus cos x sine square x dx. So we use integral to open the bracket. That means integral of cos x dx minus integral of cos x sine square x dx. Like the former examples I did, this is the minus I was talking about that was there before. and the other answer came with minus, and the minus times minus became plus. So we are going to undo them one after the other. So what is integral of cos x dx? That is sine x. Sine x. So we need to get the answer for this. Now for this now, integration of, bring this one forward, sine square x cos x dx. We solve for this separately. So we are going to have the represent this one by u. U equals to sine x, because we are looking for the x. The u dx of sine x, that is cos x. That means the u equals to cos x dx. So we are looking for the x actually. So I'm going to say all over cos x, all over cos x. That means my dx equals to du all over cos x. Since I've gotten my dx to be du all over cos x, what will I do? Just say that is integral of sine square. This has been represented as u. That means u square multiplied by cos x multiplied by, what is my dx? Du all over cos x. This cancels this. That means integral of, what is now integral of u square? That is going to give us u cube all over 3. And we substitute for u. Our u initially is sine x. That means sine x raised to power 3 all over 3. So let me join it together with this one before I write plus c finally. And neglect this du. So that means our final answer is going to give us minus power 3 all over 3 plus c. Yes, plus c. And also, you can write it like this: sine x minus, it's still the same thing. You say keep x all over 3 plus c. So please try to subscribe to this channel and share.